All right. Well, first and foremost, good morning, everyone, or good afternoon. And we appreciate you joining us for our webinar, Developing Azure Services with a .NET Cache. I'm Adam Keller. I'm a certified Scrum product owner with Alachasoft, and essentially I'm the liaison between the end clients and customers and our internal engineering team. I also have with me my associate Ron. He has well over a decade of enterprise architecture experience. He is very integral with our customers, doing technical sessions and configuration assistance. So due to that, his exposure with the customers, he's very important to our strategic roadmap for where we take NCache. So you got an expert today. So with that, I'm going to turn it over to Ron. He's going to go through as microservices and app services in Azure become more popular. We thought it was a great topic for today. So Ron?
Thank you, Adam. Thank you very much for this intro, and I'll take it up from here. All right, guys. The topic that we've selected today is using NCache, which is the main distributed .NET caching system inside Azure Services. My main focus today will be Azure Microservices. I'll talk about some architectural details of microservices. I'll talk about some details on why you need a distributed cache in microservices, what are the limitations, and then I'll also talk about app services, Microsoft Azure Web Application Service projects, where your web application may also need a distributed caching system for handling data, for sessions, output caching. So those sort of features I'm going to highlight. The main agenda that I'm going to cover today, the hands-on portion within this webinar is going to focus on the deployment architecture, how exactly a distributed cache gets deployed, and how exactly your applications would need to connect to it. So if you can see my screen, I think I've got confirmation. So let me get started with this. And mode of this webinar is listen only webinar, but you can always ask questions. You can use the question and answer tab to post as many questions as you need to. We'll keep an eye on this and answer those questions once you guys would be posting those. All right, so first I'll talk about some introductory details about Azure microservices and app services. What is a microservice, right? So this is a very common, term that we hear a lot these days. Uh, it is a platform, and it is being offered by Microsoft Azure. There are some, AWS, and then there are some third-party providers as well. Typically, I would just name Akka.net. That's also a very popular platform on the Java end, and they have ported towards .NET as well. A microservice is a platform which encapsulates customers' business scenarios, and it takes care of a certain problems that customer is having within the application. So it could be developed by a small engineering team. It could be written in any programming language. It could be stateful. It could be stateless. But it is something which is independent within the application. So it could be independently versioned, implemented, deployed, and then the nice thing about microservice architecture is that it can be scaled out independently. You don't have to scale out entire application. If a portion within the application that fulfills these characteristics, you can just implement it as a microservice. Your application can use it as a microservice resource, and then you can scale out this particular portion without having to worry about the entire application scalability. So it gives you a more granular approach towards different segments within the application. I've highlighted two common points here, that your microservices are well defined interface protocols, and they interact with other microservices as well. And then they have unique names. That's something that you get in Microsoft Azure. And then they need to remain consistent and available in case of any failures. So that's another important characteristic of a Microsoft. This is something that I've copied from Microsoft, MSDN website. So and I'm pretty sure everybody knows what microservice is. So this should cover some basic details around microservice. All right. Here's a diagram where your application type, it has a service type. It could be stateful or stateless. I've already covered that. There's another application type that could also have its own microservices, and then it may be talking to some backend data sources for code, for configs. It may be calling a web service. It could also have some data which it needs access to. And then there are, this is just an idea how microservices are architectured. There could be multiple applications, and each application could have multiple microservices, which again in turn are, a cluster of servers, instance clusters. You could have partitions within a microservice. That's primarily a stateful microservice. If you have multiple microservices, you can choose to have stateful or stateless microservices. If there are stateful microservices, you would have data partition, and then there are replicas of other partitions. So if any partition goes down, you would have the backup made available automatically. So this is part of Microsoft Azure. This is general part of microservice architecture as well, and that's what Amazon also gives you. Akka.net that also has the same kind of clustering format. So microservice is something that provides state within itself, within its architecture, by default. So I'll highlight where exactly you need a distributed caching like NCache, why exactly you need a distributed cache, and there are a few bottlenecks, there are a few issues that distributed cache is going to help address as part of this webinar, which I'm going to cover. Then I'll also talk about Azure Web Application Services. It's easier to deploy web applications in Microsoft Azure. You don't have to have entire VM. It actually cuts down on your DevOps time, the amount of expertise needed, the time it takes. It's something which is managed. So you could just get an instance-based application deployed in Microsoft Azure. It's a fully isolated, dedicated environment for your applications. You can scale it out. You can host multiple applications. It could be your mobile apps, web apps, or it could be your function apps. Whichever is required at this point, you can use it using our Microsoft Azure Web App Service model. And then it's highly scalable. I've already mentioned that. Isolation is guaranteed. You get a secure network access, and then you can also use high memory utilization and other resources which are needed. And this is a transition that most of deployments are taking, where you actually, instead of having the entire VM, hosting your application in a web farm or a web garden scenario where you have to manage the entire VM, you can have an instance-based approach where a service-based application can be deployed, and it could be a typical MVC application which can use sessions, it can use database calls, so all sort of regular MVC web application related concepts, but it's just that the deployment is slightly different. Now that we've defined Azure Microservices and Azure Web Application Services, right? So app service and microservice. Microservice in Microsoft Azure is a service fabric project, whereas web app service is an app service project. So I'll highlight details around that, and I'll talk about the networking piece that you need in order to use a distributed cache. First, I'll talk about distributed caching concepts in general. What is a distributed cache? A distributed cache is a cluster of inexpensive caching servers which are pooled together for memory and their resources for their computational power, and then their storage power. And in case of distributed cache, is the memory which presents the main storage. So you pool all the memory resources into a logical capacity. Then you can synchronize your cache updates across all cache servers. For example, any update which is applied on any given server is applied on all caching servers. Guys, just give me a moment here. You cannot do that. All right, I think there was a networking issue. All right, so please confirm if you can still see my screen and hear me fine. I'll quickly get started once again. Adam, you can hear me fine, right?
Yes, sir. I can hear you fine.
Okay, there was a networking glitch, so I think that has been resolved. All right, so a distributed cache is a cluster of multiple inexpensive cache servers which are joined together into a logical capacity. You have multiple servers in Microsoft Azure. These are going to be VMs. So NCache is deployed on a virtual machine. This is the current deployment option. NCache can also be deployed in Docker, right? So that's another deployment option. So cache server running on a VM, but it would be treated as a separate resource within Microsoft Azure. And that's the typical deployment as far as NCache server-side configuration is concerned. The next characteristic of a distributed cache is that you should have your all cache updates synchronized on all caching servers. You could have 2, 3, 4 caching servers, and they should have a consistent view of the data. Data should be visible as a same state for all the applications which are connected to it. And then it should linearly scale out for memory and transaction. As you grow your capacity, you need more storage, more resources. You can simply introduce more and more caching servers, and it should grow linearly. And then replication is another part of it, which should replicate data for any data that gets added. If a server goes down, it should automatically replicate it. Replication should be done based on operations, and data should be made available if a server goes down. So these are some common characteristics of distributed cache. Typically, your applications, be it app services, microservices, they may be talking to some backend data sources. In Microsoft Azure, you could have a SQL Server instance, which could be on the same VNet or across VNet, but you still talk to a database server. So it could be slow. It may not be very scalable. So it makes more sense to introduce a distributed caching layer in Microsoft Azure as well. And I'll talk about use cases in regards to microservices and app services as well. This is a typical deployment of NCache. So in Microsoft Azure, you would have VMs, which would scale horizontally. You could just create a virtual network, create VMs, and then install NCache on those VMs, or use our Azure or AWS images, so to speak. And then your applications can connect microservices, API apps, typical IaaS hosted apps on other VMs, or it could be app services. They can all connect to this, and it saves you trips to the backend data sources. So that's the general idea of a typical deployment of NCache. And I'll revisit this once we move on to our deployment for microservices and Azure App Services. In cloud, this would slightly change, so we'll talk about it. Okay, this is the most important slide within this webinar. I want to highlight where exactly you would be using a distributed cache in Microsoft Azure services, right? So we typically talk about web applications, web services, backend applications, Windows services, which need to access data from a centralized source, and they need a very fast repository. So that's a typical use case. In Microsoft Azure, you already have a very scalable platform. Your applications can scale out linearly, and that's a typical case with web forms and web gardens as well. So I've listed down a few important use cases that you can use inside Microsoft Azure for services. First of all, you can use it for data caching, and this applies on Microsoft's Azure microservices and as well as app services. If there are stateless services, right? Because stateful services would require their own set of partitioning, and then you would have replicas as well. But stateless do not have replicas. So one important aspect is that you have a stateless application, but you still want to have data reliability, right? So in that case, you can put data in a distributed cache. Distributed cache by design, it can cover the replication aspect and high availability aspect. So your data would be made available even for the stateless microservices. And the next benefit could be within the microservice or app service as well. If there's a web application, it may talk to a backend data source, such as a SQL Server. So SQL Server is slow. It's not something which can handle huge transaction load. In response to that, a distributed cache can have multiple servers which are linearly joined, which linearly scale out, and they're joined into a logical capacity, right? So you can add more and more servers on the fly. And in Microsoft Azure, it's very simple to manage that. You can just spawn a new VM, and you would just double your capacity as you add more and more caching servers. So data caching use case, it's first of all in memory, so it's super fast in comparison to database, and then it's a very scalable platform even in Microsoft Azure in comparison to your Microsoft SQL Server. So these are two benefits that you get in Microsoft Azure App Services and Microservices use case. You just need to introduce NCache API call, and you keep on adding data in a key value pair. Second use case is specific to Microsoft Web App Services. It is in regards to ASP.NET specific caching. So if you have an app service, you can use NCache, where your app service talk to NCache for sessions as well as for output caching data. It can also use object caching API, by the way, because this use case also applies on ASP.NET app services. So your session state typically is going to be part of the same app service instance that demands that you need a sticky session load balancing, or it could be part of the database. In either way, if it's a sticky session, it's limited, where you have to have sticky load balancing, which is the default option. And then in the database side, it's again going to be slow. And then it's a single point of failure as well. With app services, using NCache as a session store provider, first of all, it's very scalable, it's extremely fast, and there would not be any single point of failure. Sessions are replicated across servers. So that's where you get an edge, where you should consider using a distributed cache for your ASP.NET applications. And then this could be multi-site deployment as well. And this is something that I plan on covering today as well, where we would have one application deployed in one site, talks to caching servers on the same site, and then it has the ability to talk to caching servers across site as well. And I'll highlight what configurations are needed inside Azure, but that's 100% possible within NCache distributed caching offerings within Microsoft Azure. Second use case is around output caching, right? So you could use your static pages within an app service, within a web application deployed as an app service. If there are static pages, you can cache the contents of those pages. The entire page output can be cached, and you can use that page output next time when you need to access the same page. So that's another benefit. This is something that I cover in our typical ASP.NET performance and scalability webinar, where I talk about 4 different ways to optimize ASP.NET performance. So the same concept would be applied on Microsoft Azure app services, where a web application is deployed as an app service. Now, third important use case, and that's the most important bit when it comes to microservices. Although it applies on app services as well, your app services may need data sharing, right? One application service talking to another application service, or it could be data which is shared between 2 different applications. So if there are web applications which are different in nature, but they are dependent on the same data, there could be a reporting application, and there could be a consumer of that, right? Or there could be a producer in terms of product catalogs, and then there is another application which needs to depend on that, and it needs to generate some reports based on the first application. So that use case demands that your applications share data between another. So there isn't any way, you can use database to share data, but that's slow, and that's single point of failure in some cases as well. uh, Distributed cache makes more sense because your applications can connect to it in a client server model. Multiple applications can connect to the same tier, same caching tier, and then they can use the same cache resources and get access to the same data. And that's something that you can turn on. In Azure Microservices, we need to take it to another level. Azure Microservices, although these are clustered, and I've already mentioned that they could be stateful and stateless, right? Uh, there could be a requirement, and this is something that I mentioned, that your microservices may need to interact with other microservices as well, right? So by design, microservices architecture requires that your service instances may need to interact with one another, and they may need to share data between one another, and that's a very core requirement as far as microservices platform is concerned. We simply need multiple application instances share data between one another. One microservice sending some data, and it is available to other microservice instances if it's a stateful, or you could have multiple applications interact on the same lines, but within 2 microservices, this is something that's a must have, and this is why many third party providers are providing data sharing and pub sub model as part of their offerings, right? So in Microsoft Azure, if there is a requirement where you need to have data sharing handled, where one applications talk to a store, and it has a data that's needed by another application, another microservice instance, so you need a platform to handle that, and NCache offers that platform, where data is made available in a centralized manner. It's extremely fast repository, it's extremely scalable. On top of it, multiple microservice instances, different services or instances of same services can connect to this cache, and then they can use data sharing features out of it. So data is centrally available in a faster manner. Then we have topic-based, pub sub model. We have a messaging platform out of it. So a message can be sent. It could be data-driven messages, or it could be application-driven messages. A topic-based message where producer application and that's an instance of microservice that sends data to the cache, and then that message is transmitted to all the recipients on this subscriber end. And similarly, the subscribers can also be producers in some cases. So you could use pub sub messaging between multiple Azure microservice instances. It could be event driven data sharing between multiple instances as well. And then on top of it, we have event notification and continuous query system. It could be an SQL command, and based on that, you can define a data set again against which you can get data driven messages out of this. So that's the use case that you would consider using Microsoft Azure, a distributed cache inside Microsoft Azure microservices. Any questions on this?
Yeah, actually, Ron, since microservices are stateful, wouldn't the pub sub be the default offering?
All right, that's a very good question. First of all, I've already highlighted that microservices demand this architecture, right? And this is why we have some third-party, offerings such as Akka.net, right? They provide this as part of their default offering, but it's not provided by Microsoft Azure as a default offering. You need to use database for this, or some other avenues. For example, you can use MSMQ or Java Messaging Service for .NET and Java applications respectively. But it's not something which is offered as part of default offerings within Microsoft Azure. So that's a limitation within Microsoft Azure microservices. On the other hand, the Akka.net, they are coming up with a basic pub/sub notification system where they could have their topic-based pub/sub where they have actors, and they actually use this model as their default option. They also have a distributed cache, a distributed store architecture as well, where they have a key value. But that offering is also very limiting. So since that use case demands a platform which can provide this support, and that's something which is needed as part of the core architecture. This is why we're recommending that NCache should be plugged in as a pub/sub model for Microsoft, microservices, so that microservice can utilize data from a decentralized store for data sharing, and on top of it, it can use NCache as a pub/sub model. So it's not being offered as a default offering. I hope that answers your question. Please let me know if there are more questions. I'm going to move on to distributed cache deployment in Microsoft Azure. So that's something that we'll be covering today. All right. So now we have two kinds of scenarios, right? So we would have everything deployed in a single region, in a single site, within the same resource group, or within the same virtual network, preferably, right? So I've already discussed that NCache is going to be deployed on VMs in Microsoft Azure, whereas your applications can be either VMs accessing those VMs of NCache, or these could be Azure services. And we'll focus on Azure services today. VM case is very typical, where you spawn a VM, go to the IaaS, host your application in there, and then make your application connect to NCache using NCache APIs or session store provider. But when it comes to services, you need to do some networking configuration so that your service talks to NCache. So we have single site deployment where your Azure services and NCache are deployed in the same region, in the same site. So your Azure service, when you deploy it, you need to attach it to the same resource group and also onto the same virtual network as well. So that's recommended approach. You would not need any intermediary. There would not be multiple hops. It would just not slow down things. So that's a recommended scenario from our side. Second scenario, that's also a very valid scenario, that you may have multiple sites, right? We still recommend that your cache and your applications, your microservices, app services, they should always be in the same region. They should be able to connect to each other. Since NCache is a TCP/IP protocol, so it uses IP addresses and ports for all the communication, and these are TCP/IP ports. So it needs to be to be deployed in such a way that your applications are nearby. They're deployed in combination to one another. They're nearby. They're not different hops available. So we recommend that your cache is deployed on the same site where your applications are. But there could be a scenario where you're using multi-site features, where your application may need to talk to the cache on another site, or your caches need to talk to one another. So we need site-to-site communication going on between NCache as well. So that's the agenda, that I will be covering these two scenarios. Scenario one is recommended. Everything is in the single site. closer to your application. Scenario 2 is that you may have multiple sites and your application from site 1 talk to the caching servers on site 2, or it could be caching servers. For example, for the WAN replication feature, you could have a bridge between your site 1 and site 2 caches.
Question, Ron. Since you recommend single site, why is it recommended? Like, what are some of the benefits?
All right, that's a very good question. Basically, single site, the TCP/IP protocol would work. In terms of performance, it would give you more performance if there are not many hops available. It's a direct communication. So this is why we recommend that your application should be deployed on the same resource group and preferably within the same virtual network. In that case, there would not be any extra pieces of networking between your applications and NCache. So that should improve your performance. This is something which is very easily deployed in Microsoft Azure. So there are less deployment steps as well. So it's easy to use. And the major benefit that I've just discussed is the performance, less hops between your client application and the service. And just to let you know, Adam, your video feed is not coming even when you're asking questions. So that's something I think on your end. All right, so we'll talk about these two deployment options. Yeah, it is showing right now. Thanks, Adam. All right, so single site deployment for Azure services. I'll cover some detailed steps around this. I'll talk about application development, how you introduce NCache calls inside your application, and we'll use a service project for this as a reference example. All right, so this is the diagram that should cover all the details that I plan on covering within this webinar. All right. Uh, I've already mentioned that NCache servers are going to be VMs in Microsoft Azure, right? So you need to take care of a virtual network which supports these VMs, and then NCache needs to be installed on these. And then your web applications, which are deployed as app services. It could be API apps or it could be microservice apps, right? They all are service instances. There aren't any VMs underlying. So that also means that you cannot install NCache on these resources. You need to include this as part of the application resources. So there are NuGet packages that we'll be highlighting. All right. So we have web apps, and then we have API apps, and there could be microservices and other apps as well. So this is a typical single site deployment where we have same Azure Virtual Network hosting your applications as well as the VMs of NCache. And what we really are doing in this is a point to site VPN between your web applications and your service apps and NCache service. So that's what the overall networking looks like. It's part of the same virtual network where we will actually use a service project. We'll introduce NCache resources in it. Then we'll create server-side resources for NCache so that our VMs are up and running. And then we'll simply come back to the application and attach our application to the same virtual network where our NCache VMs are existing. So that would just make it a single site and using the same virtual network as of our caching service. So let's go through the steps for these. All right, so first step is that you have NCache server-side Azure environment setup. And that actually means setting up Azure virtual machines for NCache. And this step is common for all sorts of deployment, whether it's a single site deployment or a multi-site deployment. For single site deployment, you just need that your NCache servers are set up. They are VMs, and then NCache is installed on those. So I'm going to quickly take you to our Azure portal, right? And if I just go to the resource groups, I've just created a resource group. Let me just sort it. My first resource group is demo resource group 1, right? And here we have all sort of VMs. For example, we have demo VM 1, and then we also have demo VM 2. And as a matter of fact, I have used the same virtual network. My bad. All right, I've used the same virtual network for both of these demo machines. Let me just quickly show you let me just bring it right here. All right, so we have demo VM1. If you look at this, it's deployed in West Europe. And then we have demo VM2. and then there is a demo VM VNet one, right? If I click on it, I can see demo VM1 and demo VM2 part of this, and these are the IP addresses 10.4.0.4 and 10.4.0.5. So that represents our two NCache VMs. And if I quickly take you to this environment right here, so what I've really done is I've created a VM, an empty 2012 or 2016 image would do, and then I've gone to our Logisoft website, and all you need, there isn't any special installer for NCache. You just need to use the existing installer, go to the download page and download the 60-day trial of NCache from our website. And once you've done that, I've installed NCache on demo VM1 and demo VM2. And then I created a demo VNet cache as well. The cache creation steps are very simple. You just need to go to demo cache, pick the caching topology, async, and specify demo VM1, and then I think demo VM2 should pick the IP as is. Yes, it does. So these servers are able to talk to one another. One additional step that I've taken, if I come back to the presentation, these are the steps that are needed for setting up NCache servers for Microsoft Azure. You create an Azure virtual network, right? That is something that you may already have in your environment, and then you create VMs on those Azure Virtual Network. So you could have dedicated set of VMs for NCache, server 1, server 2, server 3, and then you make sure that you keep the same subnets. That's something that we recommend, and then you install NCache on all those VMs. And then one other thing is that you open NCache ports for communication. There are two kinds of ports, two kinds of network considerations that you need to have. One is that you need to have internal firewall disabled, and then on the network where these VMs are, you should have a network security group, right? So for example, demo VM1 uh, network security group, we would have these ports opened already, right? So if I quickly show you the NCache ports, all we need is port 9800 and port 8250. This is for inbound as well as for outbound communication, port 9800 and 8250. So this would make sure that any application trying to use NCache, which uses port 9800, is able to connect to these caching service. And then any application which is trying to manage, for example, there could be another VM which is trying to manage this and could be cross virtual network, but it's part of the same resource group. These network security group allow you to have these communication going on these ports. So that's it. That's the consideration that you need to have. I've turned off firewall on the caching servers themselves, and these ports are open, and I've just created a cache. And I can see the statistics. I can just run a stress testing tool application on these machines directly, and I can quickly, there's a bit of lag, so please bear with me, and I can just simulate some stress on these as well. So we have, I'm sorry, VNet 1 cache, and we just run and simulate the activity on these two caching servers. So that's how easy it is as far as server side setup is concerned. Now you need to come back to your application and have a look at that. Yeah, there you go. So we have activity coming in, so we're good. I'm just going to close this down. All right. Any questions on the server side configurations? Please let me know if there are any. So I think that's pretty straightforward. I'm now going to come back.
Yeah, I actually have a question. There was quite a few steps there in the configuration. Is all that done within Azure? And part two of the question, is there any documentation for all of these steps?
Okay, got it. So yes, first of all, these are Azure specific steps, right? It's like setting up a caching server, right? In out of in non-Azure environments, what you would really do is you would have a server, you would just join it to a network, you would install NCache, you would have operating system installed on it. It could be VMs as well, or you talk to a hosting provider and take care of that. So these are some Azure specific steps, and we have detailed Azure documentation available on our website as well as how to create a virtual network in Microsoft Azure, or how to create a VM, or how to set up network security group on Microsoft Azure. Complete documentation can be made available directly from Microsoft Azure resources. So you can go to MSDN, go to Azure portals, and all these steps are documented. I'm just listing down these steps for NCache that you need to create a virtual network, so that people understand that you need a virtual network. You install NCache, you spawn an image, then install NCache on it, and then set up the networking piece together. So yes, everything is documented on our website as far as what is needed for NCache, and then everything is documented on Microsoft Azure on how to create a virtual network, how to go through these configurations. All right, so I hope that answers your question. Next, now that we have virtual machines configured, I've created a cache cluster as well. Next thing is that I need a web application which can talk to this cache cluster, right? So I'll quickly come back to my presentation right here. Right, so from your application standpoint, what you really need is you need point to site network configuration between your application, your app service, and NCache. So first of all, I've done that already, right? Just to highlight that. Now, if you come back to the resource group, we have demo resource group 1. So we have demo virtual network gateway, right? We created a gateway on this, right? And then we have a point to site. This is a virtual network gateway which uses demo vnet. That's the main virtual network for our caching service. So if I come back right here, if you look at this diagram, it actually uses a virtual network gateway here, which is part of this virtual network. And then my applications, which I'll deploy shortly, is going to have a point to site communication going on between this. So that this is attached to the same virtual network. That's the requirement of Microsoft Azure. In order for your app service to talk to resources which are on a virtual network, for example VMs, you need to have a point to site setup. So coming back right here, so we have demo resource group, and if I show you the point and site, let me just come right here. If I show you the point site to site configurations, we have this IP, which is a general IP for our app services. So once an app service gets deployed, you click on it and then attach it to the corresponding virtual network. So I'll come back to my project. I think I didn't show it earlier, but this is a sample application. It's a service app. I'm going to show you what is needed. So if you right click on it, you have NuGet packages available for Microsoft Azure. So I have, for example, we have lachisoft.ncache.sdk. These are privately available with us, right? These equip your applications with all the NCache client-side resources, because there isn't any installation of NCache on the client side. Typical NCache deployment is that you have client installed, you have a server installed, so that covers it, right? But with services, it's an instance, so you don't have access to underlying VM. So in that case, you need the NuGet packages so that all the resources are made part of what you need inside the application. So this is the NuGet package that I've already installed. What it really has added all the NCache client-side libraries, right? So that's one. Second, it has added some configs as well. So we have client.ncconf. That's the main file which connects to any cache. For example, I already have settings to connect to VNet1 cache. That's the name, and then I also have the internal IP addresses to connect to those. And next thing is that I publish this application, and then this application should be able to access 10.4.0.4 VM1 and 10.4.0.5 VM2. So I need to make sure that there's a point to site communication where this public IP is accessible to my application. Only then it would be able to connect to this cache. So coming back to the application, I am showing some cache calls. So within this MVC project, we have a main controller where we have this cache instance, and then I'm using cache instance.initialize cache. Let me just go to this method right here. So this is the initialize method, cache.initialize cache, and then we also are calling cache.insert to add an item, cache.delete to delete that item, cache.get to get the item back. And then if I'm not too sure if I have performed some load tests. Yeah. So there is another method, load test, which actually loads item. 1,000 items are loaded in the cache, and then those are retrieved as well. So this should take care of the main logic as far as our application is concerned. There are some views that I'll show you. So we have delete, get, index, and load test as well. And these are simply being called through our through our application. So what I'll do is these are basic NCache calls. So what I'll do next is I'll just deploy this to Microsoft Azure. So I've already set up all the resource groups and networking piece right here. But what you really need is, if it's a Microsoft Azure app, you just create new your web app name based on your subscription. Uh, let's wait for some time so that it picks the subscription. There you go. So it automatically picked Visual Studio Enterprise. And then resource group, I'll just plan to use the demo resource group 1, so that I'm using the single site deployment, so it's part of the same resource group. And then I pick the service plan and then just choose create. You could just put new here as well, so that even the location is West Europe. Right, choose OK on this and then choose create, and it will automatically get started on that. Since I already have done this, so what I'll do next is I'll simply go to my web config, make sure that it's using vnet cache 1, and inside client.ncconf we have the vnet 1 cache. So this application is going to be deployed to the same site, same resource group, and then I'll attach it to the virtual network, which is part of my NCache servers VMs. Any questions on this? I hope it's pretty straightforward, but please let me know if there are any questions around this. Coming back to Microsoft Azure environment, if I go to the resource group 1, we should have this application somewhere. There you go. If you click on it, and then on the networking piece of this application, once it's deployed, right? So right, so you go to the networking, you click on it, and then it's already connected to demo vnet 1, right? uh, I've already done this, right? So in your case, since once you make a point to site connection onto your virtual network gateway that you have on demo resource group 1, right? Bringing back this up right here. So once you create a virtual network, create a point to site, and then this app service IP is exposed. After deploying your app service, you need to attach it to the virtual network, right? So this is something that's an extra step which is needed right here. So my application, I hope it's loaded. I'm waiting it for it. Yeah. Now on the server end, I'm just going to clear the contents, and I'll just insert an item. It's successfully added in the cache, and you can see one item added. I'll just quickly get it. I'm sorry, I can't really show you the counters, but it actually indeed retrieved it, and then I can delete it. Right, so successfully deleted as well. And since it's part of the same virtual network, it's a lot faster in comparison. Now I'll just simulate some load tests. I'll just add 1,000 items, and you should see some activity there. There you go. Right, so requests per second, and those items are being added, and then you could see about 600 items here, about 400 items here, and then it's now retrieving those items. So that's a typical deployment of your services, be it microservices, be it app services, API apps, any application deployed in a service model. So you just need to introduce NuGet packages, create a point to site connection to NCache VMs, through virtual network gateway, and then your application instance can be attached to the VM. So these are all Microsoft Azure networking configurations. NCache just needs private IP addresses to be exposed on the TCP/IP channel. So that's all what we need. Any questions?
Yeah, there was a question from the audience, Ron, about if you could share any scenarios where the same VNet or different VNet scenarios would be required.
All right, so that's a very good question. Yeah, so I can actually talk about it. All right. So basically, scenario one is recommended, right? But there could also be a scenario where we have multi-site deployment, where one application deployed in site one talks to your cache servers, which are another site. Not recommended, but that's possible. Scenario could be that your on-prem applications need to talk to caching servers which are in Microsoft Azure, or vice versa. We have a client deployment where they had all their applications deployed in Microsoft Azure, but their data sources, their caching resources were all in on-premise. They were making a transition from on-prem to Azure. So that's one scenario. Second scenario could be multi-site sessions. There could be a geographical distribution of your application servers through global load balancer. Traffic from within one region goes to a regional data center. So you could have two data centers and they all talk to a cache within their data center, but occasionally their traffic can bump from one site to another site. So in that case, they could have the other site cache that need to be accessible. The third scenario could be that your cache servers needs to talk to one another across sites. There's a bridge feature for WAN replication. If a site goes down or you need to make it down for maintenance, you need the backup of that. So cache sites need to talk to one another. In that case, you need a multi-site deployment. So that these are a few scenarios, and there could be more as well. I hope that answers your question. So next, since we have less time available, I think in last 10 minutes I'll cover the multi-site scenario as well. The configurations are almost similar. uh, we have our web apps or Microsoft services or app services deployed on one Azure virtual network or in one site, and then NCache VMs are another site. And for that, what we really need is a local network gateway here and a virtual network gateway here, and then we need a site-to-site connection between these two. Again, these are all Microsoft Azure settings that equips two sites to connect with one another using a site-to-site connection, and NCache utilizes those. And internal IPs are mapped on each site. So your NCache server internal IPs are mapped onto uh, your application services virtual network, and vice versa. And for that, I'll quickly show you the configurations. If I bring you back to resource groups, we have demo resource group 2, right? So that's another virtual network. Uh, and we have demo VNet 2 right here. And I have two boxes on this virtual network as well, demo VM3 and demo VM4. So this environment right here is 10.4.0.4. That's on another virtual network. It could be cross site as well. I'm just using the analogy of another virtual network as another site, but it could be a cross site. It could be another data center in another region in Microsoft Azure. So what you really need is keep the same settings for this as I've already explained. You keep the VM part on the same virtual network, same subnet, create a cache, start that cache, and now your application needs to connect to a cache which is a cross site. For that, you need a site-to-site communication going on. And if I come back right here on this demo resource group, since we have a demo virtual network and demo virtual network gateway, yeah, there you go, virtual network gateway 2, right? So that's a gateway on the second site. So if we go to the connections, we have demo 2 site to site connection. So we have a site to site connection to the demo 2 local network gateway. So that is something that I've configured, right? So that enables my virtual network 1 to connect to virtual network 2, which are across site. So this is exactly what we've done. I'll just quickly show you the NCache application. That nothing changes here. You just need to change the name of the cache, and then you should have the IP addresses to connect to the caching servers, which I have as part of the stack. So VNet 2 cache, and I'll be using the same application to now connect to. I just need to publish it one more time. And notice I still publish it in demo resource group 1, whereas our you know our virtual machines are in demo resource group 2, and this is the VM3 right here where we have 2 caching servers. So I'll just publish this one more time, keeping a site-to-site connection already configured. I'll just publish this, and same application would now go across network, across site from virtual network 1 to the virtual network 2, and would be able to connect to this. So I'll just wait for it to be published, and then I'll come back right here and show you the networking piece one more time. So what you really need is same setup for virtual machines. Keep the same virtual network here, same subnet, spawn the VMs, install NCache on them, disable the firewall, set up the network security group so that NCache ports are open, and then you need a site-to-site connection between your applications as services connecting to NCache service. So if you already have a virtual network where your app services are attached, you just need to make sure that virtual network 1 is now able to talk to virtual network 2, and then they're across site. And this is exactly what I've done in Microsoft Azure as well. Oh, I'm sorry. So publish was successful. I think this was it. Let me just close it down, and let me just insert an item. All right, and let's see if an item has been added. There you go. So an item has been added. So now it's talking across site from one site to another. And then if I get this item, it would just be retrieved. If I delete it, this item would go away from my demo VM3. No items are there. And similarly, I'll just simulate a load test where I'll start using the same environment, but I'm just simulating some activity on it. So now my site 1 app services are talking to site 2 cache servers. They're going across site. It's not a recommended scenario because there's a WAN replication or WAN latency which may become part of it. So we recommend keeping everything in the same site, but it's possible. There could be a scenario where you're based on multi-site sessions feature, for example, based on WAN replication feature of NCache, or it could be that on-premise applications talking to Azure or Azure applications talking to on-premise, vice versa. So these are the requirements, and our load test is now complete as well. So that successfully got executed. So that covers our Azure deployment. A few things that I would like to mention at this point that you have, and there's a Redis comparison as well. We're talking about Azure, so we'll definitely talk about Redis. So it's available on our website. NCache is 100% .NET. It's developed in C Sharp. It's fully supported for .NET and Java. In comparison, Redis behind the scenes is on Linux. You don't have control on the VMs. In NCache, you have full control on the VMs. You could run server-side code on NCache as well. Uh, the Microsoft version of or Windows version of Redis is not that stable. It's the Linux version which is used behind the scenes and provided as a service model. And then NCache can be used on Dockers as well. If you plan on using NCache on the server side Dockers containers, you could use that. And then I'll also talk about some details in regards to deployment options. Uh, you just install NCache server portion. You get a Azure release from our end. It's a server only release, and then you need the NuGet packages to make your applications equipped with NCache, and that's something that you can also get hold from our support or sales team. So that's something that's not publicly available. That's intentional. But you just need to request to us, and then we'll provide you the release for Azure as well as the NuGet packages. And after that, it's just the networking piece that you need a single site setup or multi-site setup. Typically, we recommend single site, and in that case, you need a point-to-site communication. And in multi-site, you need a site-to-site communication. So that completes our presentation, and I think we've done it in well within 1 hour marker. Please let me know if there are any questions. Uh, and over to you, Adam, as well.
Okay. I'll just give it a second just to see if there's any questions. And while I'm monitoring the question pane, I'll say thank you for your time, everyone. Like Ron mentioned, if you're interested in actually getting your hands on NCache and using it in your environment for an evaluation, our support team can get you all the licenses needed for a 60-day evaluation. If you're interested in talking with Ron or any other of our solution architects, a one-on-one demo or even a technical session about your specific use case, also don't hesitate to reach out. That's what we're here for. So yeah, let us know if we could be of service and if you would like to discuss NCache, more in a one-on-one fashion. But again, we appreciate your time and yeah, thank you.
Thank you very much, guys.